Here's example 16 with trig identities. So again, if you want a copy of this packet we've been using, if you want to follow along with that, check the video description. There's a link in there. You can click that link and open up this packet, print it out, and follow along if you'd like. So tangent squared of v times cosine squared of v plus cotangent squared of v times sine squared of v equals 1. Okay, so let's go back to our general process here from an earlier video. Always start on one side and try to make it look like the other side, and usually start with the more complicated side. So I think we'll all agree the left side is more complicated than the right. So let's start with the left and try to make it look like, try to make it show that it equals 1. Okay, so tangent squared of v times cosine squared of v plus cotangent squared of v times sine squared of v. Okay, so what can we do here? So we see, okay, here's tangents, cotangents, cosines, and sines. So one of the things, first of all, we see a bunch of trig functions being squared. So we might think Pythagorean identities. Okay, but this is kind of a mess. You know, we have trig functions that are being squared and multiplied together. So that doesn't really jump out as Pythagorean identities. We can go that route. It's probably not good to do it yet. Okay, maybe we don't want to start with that yet. Another thing to try is, there's factoring, or that's another thing to think about, factoring, but there's really nothing we can factor here because this is a tangent, a cosine, a cotangent, and a sine, so there aren't any common factors to pull out, okay? But what's another thing we can do? Well, here's a cosine and a sine, here's a not sine or cosine, here's a not sine or cosine, so let's convert everything into sines and cosines. So rewrite expressions in terms of sines and cosines. Let's try that. So first of all, we know that tangent, okay, we talked about this in an earlier video, but in case you didn't see that video, we'll explain it again. We know that tangent of v is sine of v over cosine of v. Okay, so it's going to be true then that tangent of v whole thing squared is sine of v over cosine of v whole thing squared. But when you square a quotient like this, that's the same thing as the top squared over the bottom squared. Okay? And remember, this is just a long way of saying sine squared of v over cosine squared of v, right? So remember this type of expression here. So tangent of v whole thing squared like that, that's just a short way of saying, or sorry, that's a longer way of saying tangent squared of v. Okay, so tangent squared of v is just a shorter way of saying this. Okay, and remember, it's not the same thing as this. Okay, tangent of v squared. If you just say that, that's the same thing as this, which is completely different from this and this. Okay, completely different. Be very careful about that. Okay, so this right here, this is not what we want. That's not what we're dealing with. Okay, that's not what we have right here. Okay, so be very, very careful about that. Okay, so anyway, just a lot of details here just to show that tangent squared is the same thing as sine squared, oops, we're up here, sine squared of v over cosine squared of v. Okay, cosine squared of v is just cosine squared of v. So remember, we're converting into cosines and sines, so we'll leave cosine squared as it is, and then plus cotangent squared for the exact same reason that we talked about here. Cotangent is cosine over sine, so if you square everything, then you'll end up with cotangent squared is cosine squared over sine squared. Okay, so cotangent squared, so that's the exact same reason as tangent squared is sine squared over cosine squared. Okay, so for the exact same reason, cotangent squared of v is cosine squared of v over sine squared of v. And since we're converting into sines and cosines, leave the sine squared over here as it is. Okay, so now what happens? Cosine squared of v, cosine squared of v, they cancel. That is great. That's wonderful. Sine squared of v, sine squared of v, they cancel. That's great. That's wonderful. And then this is sine squared of v plus cosine squared of v. And what's that? So that should jump out at us as Pythagorean identity, one of the most important ones in all of math, one of the most important identities in all of math. So sine squared of v plus cosine squared of v, well here, sine squared of theta plus cosine squared of theta is 1. Okay, we have v instead of theta, but that makes literally no difference at all, absolutely no difference. Just completely no difference at all there. So sine squared of v plus cosine squared of v is 1. Okay, whether it's theta or v or u or w or t or z or x or y, it does not matter what's here. It could even be a more complicated expression. As long as these two things are the same, okay, theta and theta, v and v, okay, they're the same thing, so that just equals 1. And is that what we wanted? Yes, it is exactly what we wanted. So that's good, check mark, we're done, we're good to go. That's it. So that's it for example 16. Again, what did we just do? All we did was convert everything into sines and cosines, cancel, Pythagorean identity, and we're done. Okay, that was it. So the only tricky thing, which really isn't even that much of a tricky thing, I guess, is since tangent of v is sine of v over cosine of v, then tangent squared of v is sine squared of v over cosine squared of v. Okay, so it is something that, you know, we could just take it for granted, but we want to be careful when we take things for granted like that, but it is something that you will want to show and understand how it works, and that's how we do that here. Just, you know, tangent squared of v, that's a short way of saying this, and then since tangent is sine over cosine, then this thing squared is the same thing as this thing squared. It's a basic rule of algebra that when you square a quotient like this, you can square the top and bottom separately, and then just remember that shorthand notation for trig function squared. Okay, so tangent squared of v is sine squared of v over cosine squared of v. Okay, so that's why that's true. Anyway, same thing with cotangent. Okay, cotangent squared of v is cosine squared of v over sine squared of v. Okay, so really nothing too complicated going on here. Okay, so then cancel, simplify Pythagorean identity, and we're done. So that's it for example 16. Example 17 coming up next.